Exercise 3G, question 9. In the book, here it is. I've copied the diagram. Diagrams are important. They're probably going to need some extra annotation added to them, and they're going to make the question a lot easier. This question is about Hugh rowing a boat. So he rows the boat across this lake, P to Q, and then he walks Q to R. And if you look a bit further down, show that the time taken, so we're trying to work out an equation for time. So what I've done is they've given the speed for rowing 3 and the speed for walking 6 kilometers per hour. I've taken a note of that. I know that speed is distance divided time in kilometers per hour. Therefore, time is distance divided speed. So this is sort of assumed knowledge, speed, distance on time. I can rearrange that to get time, distance on speed fairly easily. In this question, we need to have a little bit of geometry knowledge, and we'll need to know about the circumference of a circle, and all of that type of stuff would be assumed knowledge. Okay, so let's start the question. The first thing is they ask you to get the distance PQ, right? Now, if you've done circle geometry before, this will be fairly straightforward. If you drew in a line there, you would know that this is at a perpendicular. This can be, if you've got a diameter of a circle, choose any point, so I'll choose a different point. You go from the ends of your diameter, right, to some point on the edge of the circle, you always get a right angle. Okay. Knowing that it's a right angle makes the question a bit easier because I know that that's whole length is 4. I'm trying to work out PQ. So I could say cos theta is adjacent on hypotenuse. Now, right, that's the adjacent length. That's the hypotenuse. This would be the opposite. I'm not interested in that. So the adjacent is PQ. The hypotenuse there is 4. And so therefore I could say distance PQ is 4 times cos theta. 4 cos theta. Now if you didn't know that little rule, you can still work it out. I'll draw another circle, put in a diameter. We want P to Q. There's the center of the circle. You've got this line already drawn in. You've got this angle. So what you could have done is say, well, that's 2, that radius. You could have put in another radius, 2. Then you could have said, that's an isosceles triangle. So if I split it down the middle, I get a right angle. Now that's my adjacent. Adjacent equals cos theta times hypotenuse. So it would be 2 cos theta. So just this distance in here, right? That's 2 cos theta. That distance there's the same. Right? And then you could have put the two cos thetas together to get the 4 cos theta. Right? So hopefully you know isosceles triangle. Yeah? Get 2. What does that mean? The 2 lengths of the triangle are the same. That means the 2 angles are the same. And if you split this down the middle, right, so you bisect this angle, it comes out at a right angle down the bottom, and now you can do SOHCAHTOA, cos is adjacent on hypotenuse with it. Now the distance QR, you actually need to think about this line, right, because QR is on the outside of the circle, so you're now dealing with the sector of a circle. Just maybe draw it bigger here, like that. from Q to R. Right, so you need to know what fraction of the circle you work. Right, so you would need some angle there. I'm not sure what it is yet. We'll work it out in a minute. That's like circumference of a circle, yeah? But just some fraction of the circumference. So circumference is 2 pi r. 2 pi r. But we only want a fraction of it. It's some angle divided 2 pi. Okay, so what is this angle in here? Well, by drawing this line in, so I got my sector of a circle, I could, figure, oh yeah, well that's also 2. This is an isosceles triangle, so that angle there is the same as that angle, like the isosceles I drew before. This angle in here would be 180 degrees. I think in degrees when it comes to geometry, so I'm just going to write degrees instead of 2 pi, minus 2 theta. And therefore this angle here is 2 theta. Now again, if you know your circle geometry, you'll know that the angle at the center is always double the angle at the edge of the circle, as long as you're subtended by the same arc. But for those of you that haven't done the circle geometry, you would be able to work this out, because you know that that line there is 180 degrees. Yeah, this will look a bit confusing, but I'm talking about that line there, right? So if that angle there is 180 minus 2 theta, what's this? Well, I could work it out, because I could say 180 degrees from the straight line has to equal 180 minus 2 theta, right? That one in there. Oh, and did I say how I got that one? I mean, that's coming from this triangle, right? This triangle in here. Triangle has 180. Theta, theta has to add up to 180. So that's 180 minus those 2 thetas. Yeah. Now this straight line is also 180. Let's pretend we don't know that angle. So I'll just write mystery angle, question mark, minus 180 from both sides, and you'll get 0 equals minus 2 theta plus, and can you see it yet? Let's add 2 theta to both sides. So there's your angle, 2 theta. Right. So we're looking at the distance QR. We start with circumference of a circle, 2 pi r. Now what is the r? The r is 2. Geez, there's 2's everywhere here. Then we want the fraction of the circle, and the fraction of the circle is 2 theta out of 2 pi. So I'm sticking to radians. Right? 2 pi radians would be the whole circle. This works out nicely because you get those cancelling out. You're left with 4 theta. Right. Now if we thought about time next, the questions about time. The time to rho from P to Q. Let's write the time to rho. Oh, damn this pen. Okay, the time to rho from P to Q. Time is distance on speed. The distance is 4 cos theta. The speed for rowing is only 3. Right, well, there we go. The time, that's finished. The time for Q to R, that's his walking. Well, the distance is 4 theta. The speed is 6. Okay, so if I put all that together, I'm going to get rid of my distances now because we're really interested in time. I'm going to have a big time equation, basically just adding these two together. So we've got 4/3 cos theta plus, now 4 on 6, that's 2/3 theta. Okay. Now, if you couldn't work it out in a test, the question gave it to you, right? So just in terms of test technique, you would not be locked out of that question. You could still take this time equation and do parts C and D. We have to set the derivative to equal 0, as you would expect. I don't know why that came up. I want this one. Okay. Show. Get your notation right. The derivative of the time equation with respect to theta is, okay, derivative of cos is minus sine, and the derivative of 2/3 theta will just be 2/3. Hopefully you're not going to get confused. Like if you had y equals 2/3 x, what would the derivative be? It's just 2/3, right? Yeah. So don't get confused just because it's got a theta there. It's like you're dealing with an x. So there's my derivative. If I want to find a maximum or a minimum, we're going to set it to equal 0. So the derivative equals 0 when this equation equals 0, and 4/3 sine theta plus 2/3 equals 0. How about we add the 4/3 sine to both sides, so we would get 2/3 equals 4/3 sine theta. Let's multiply both sides by 3. I have to go up here. So I get 2 equals 4 sine theta. Divide both sides by 4. We'd have 2 divide 4, that's a half. Now, the domain has to be less than 90 degrees, or pi on 2 radians. Why is that? They do tell you in the question, I noticed, but you can see it in this diagram. If I went bigger than a 90-degree angle here, so theta's there, right? So imagine this line got taken out to 90 degrees to make a 90 degrees. Well, then I wouldn't be doing any rowing. I would just be walking the whole way. If that angle comes down to be 0, it's like Q would come all the way down to R then. So if that angle is 0, then you're just rowing the whole way. Right? So that's why you have this domain restriction. You can represent that on your sine diagram. When my computer stops malfunctioning, there we go. So the sine diagram, always draw the sine diagram for the optimization, unless you want to go to second derivative. We haven't covered that yet. But you have to show that you're dealing with a maximum or a minimum. Now, when I first did this question, I thought we would be minimizing time by doing a combination of rowing and then walking. I thought, oh, it's probably trying to save time to get from P to R. But plugging in, when I tested this sine diagram, I won't bore you doing it now, but actually you get a plus there from your derivative. Make sure you actually plug in numbers into the derivative. You want to know if you've got positive gradient or negative gradient. You want to know if you have an increasing rate of change, right? Or sorry, an increasing time, not an increasing rate of change, a positive rate of change or an increasing time, or a negative. You actually maximize time at pi on 6, which is kind of interesting. It was a bit unexpected for me, right? But it became pretty clear when I started working out what the time was. So 4/3 cos pi on 6 plus 2/3 times pi on 6. Right? I'm now going to the time equations to find out what this time actually is. Cos of pi on 6 is root 3 on 2, so it's 4 root 3 on, right, so all that cos pi on 6, the whole thing is root 3 on 2, so I have 3 times 2 is 6, plus 2/3, we're going to have 2 pi on 18, let's just write 1/9 pi, or pi on 9, could tidy this one up as well, 2 root 3 on 3 plus pi on 9, and we get a time of, the calculator's going to make it a decimal, so approximately, we'll go 3 significant figures. I've got to remember what I'm doing. 2/3 root 3 and pi on 9. Okay, calculator, 2/3 square root 3 plus pi divide 9, and I get 1.503. So 3 sig figs would be 1.50. That's thinking. There we go. 1.50 hours, which is actually the maximum amount of time that you could take to get from P to R. Now this is really important. That's the only stationary point, but the question also asks about the minimum amount of time. I'm running out of room for it. So I'm going to have to get rid of this and do it here. The minimum, that was the maximum. The minimum time, there's no other stationary points, right? But the way you find it is you test the boundaries. Basically, we're testing if the angle's 0 and he rows the whole way. Yeah, so the minimum time rowing the whole way, where theta equals 0, right? That would be here, time equation, 4/3 times cos of 0, which is 1, plus 2/3 times 0, which is, funnily enough, 0. So we get 4/3 of an hour, which is actually quicker than what we had before. So he rowed the whole way. It's quicker than if he goes at a 30-degree angle. Walking the whole way, maybe that's the quickest way to go. And it shouldn't be too surprising because he can walk twice as fast as he can row. Now, I've used the equation here, but I didn't really need to, did I? I think I'm overcomplicating it. Like if we're rowing the whole way, we're doing a distance of 4. We can just go straight to the so we could just go straight to saying the distance is 4 kilometers, right? The speed is 3. Right? I don't actually need my fancy time equation. Done. And same as walking. If we're walking the same way, we're doing half a circle. So a whole circle is 2 pi r, where r is 2. We're only doing half. So we end up with a distance of 2 pi, right? A distance of 2 pi kilometers. The walking speed is 6. So we get 1/3 pi hours, and that's the quickest way. If pi is about 3.14, and you divide that by 3, you're pretty close to 1. It's a bit higher than 1, maybe 1.04 or something. So walking the whole way, no rowing. That's the quickest way to get from P to R. The take-home message is don't forget about the edges of the sign diagram. Sometimes an optimal solution can be found on the boundaries. Okay, thank you.